Uh, okay. Uh, so this is about mobile installations. If you put your HF radio in, well, could be a VHF radio. In fact, mine is a VHF UHF radio in my car. Some of the things you need to account for. Uh,
What?
here's a typical mobile installation.
Oh, they see you coming. Wow.
Oh, you see stuff like this. Some of people are unbelievable.
Wow, that's amazing.
So
No red flags on that? You don't have to put flags on
I guess it didn't go back far enough.
that?
Um, on power connections, you want to try to make a direct connection to your battery. You don't connect your radio to your auxiliary power outlet, what they used to call a cigarette lighter. Uh, those won't handle the kind of current that most radios take. So you want to run some heavy gauge wire as short as you can directly to the terminals on the battery, or at least to the positive terminal and the negative terminal to the battery ground connection on the chassis. Um, there's a lot of noise sources in an automobile, particularly older automobiles. The charging system for the battery tends to uh, switch on and off, so it's generating some broadband noise. The fuel delivery, in other words, the fuel pump that's back in your gas tank, uh, is another motor that gets turned on and off, so it's generating noise every time it does it. The computer or multiple computers that are in modern cars are not necessarily well shielded as far as amateur radio is concerned. They shield them enough that they don't affect other things in the car, but they don't really care about whether or not your radio picks up that noise. um, Most mobile antennas are typically going to be short relative to uh, a full quarter wave or 5/8 wavelength. So that means they're compromised and they're not going to be as efficient as a full sized antenna. Just like your handy talkie, when it comes with that little rubber ducky that's like, what, 6 or 8 inches long, that's a very compromised antenna. Also, when you do things to physically make the antenna shorter, like adding loading coils or capacitive hats on the top, uh, it tends to narrow the bandwidth of it as opposed to a full size antenna. So it means that you have a smaller section of the band that you can tune and get a good SWR. The wider the bandwidth, the wider that SWR curve is. One of the elements I mentioned to um, improve the radio and or the antenna and make it physically shorter is to put a capacitance hat on the top of it. Um, and it's just some perpendicular elements. It may be two or four, or actually several of them connected together like a disc. There's different formats, but they all basically behave the same. They add capacitance to the antenna. Here's an example, isn't necessarily a mobile one, but these are capacitance hats uh, to make this dipole much shorter than it would be if it was a full size.
Would you show where the hats actually were on that picture, please? There, okay. Just wanted to
Those,
make sure I was right. Thanks.
yeah. In this case, it's not at the top because it's a
Right,
horizontal antenna.
right. I just wanted to make sure it wasn't something else. So good. Thank you.
Okay, here's a little simple example where we have a quarter wave antenna, and this red line represents the current or the power uh, in that antenna element. And you can see that it's maximum down here at the feed point, and it decreases essentially to zero at the end because there's nowhere for current to go when it gets to the end. But you still have maybe 100 watts. So that's why I said earlier, you don't want to touch the end of the antenna. So even though you have almost zero current, you have a very high voltage because you still have 100 watts. If you have like a typical mobile installation where it has a loading coil on the bottom, we call that base loaded, you'll see that most of the current is in the coil, and the current that's in the whip is much lower. That's why it's less efficient. It doesn't have as much radiated power because the current that's in this coil doesn't radiate. Because of the coil itself, it cancels itself out. So the power stays in the coil.
So why would
Sometimes
you want to do that?
because you can't run around with a 6 or 8 foot antenna on top of your car.
Right, but if you're going to put the coil down there and it's going to basically, like you said, cancel it out, I mean, you're not getting.
Well, it's it's a matter of how high the antenna can be. So if there's a maximum limit and it needs to be longer, then doing this makes it electrically longer but physically shorter.
Okay.
Now you can move it up to the middle, which is called center loaded,
Which would be better
and
because
you
it's up
get
in the air.
some radiation down here on this part
Hmm.
and a little radiation up there. I don't necessarily think it's any better, and you don't see that necessarily a lot. Or you can add a capacitance hat. It's still a shorter antenna, but you can see that the current on most of the element is much higher. So it makes it more efficient. Not
Right.
as good as a full size, but a lot better than this one.
And all of them have radiation coming from them. I mean, it's just
Yes,
depending on where it's coming from. Like you said, the base loader is going to stop the radiation at the bottom.
right.
And then, so that's as safe as far as radiation is concerned, but not for the.
And actually, you really don't see that many capacitance hats. Of course, most cars with mobile installations, well, except for that one I showed, although that was some UHF stuff, uh, are going to be VHF, 2 meters, 70 centimeter. Uh, and in those cases, like 70 centimeter isn't really a problem for having a full size antenna. 2 meters can be if you want to do a full quarter wave on top of your car. Uh, that's 3 foot above the top. So, and if you really want to do it right, you do a 5/8 wave, which kind of gets there even more. So you start hitting tree limbs, and
bridges.
maybe a
A
power
road.
line, which you really don't want to do. Another thing that you may see, it's also rare, is a corona ball. Because, like I mentioned, out at the end of that antenna, because there's almost no current, you can have an extremely high voltage. And if the end of that antenna is kind of sharp and very small, you have a high energy density because there's not much surface area to spread the charge over. So it can actually, uh, if you ever seen like the Van de Graaff generators with the big ball and you get close to it and it sends arcs out to your finger and stuff, uh, you can get those kind of discharges off the end of an antenna. Sometimes you can see it at night. The corona ball is there to prevent that because it allows the charge to spread out because the charges don't like each other. So they try to separate themselves as much as possible. So they'll spread out over to the entire area of that ball. So the charge density is much less than it is at that point source.
So, in other words, instead of having like a lightning strike from that ball, you're getting a whole glow from the ball.
Well, maybe, but
I mean,
yeah,
like it's over the entire sphere of the ball. It's not just a
right.
contained area.
It's
Okay.
probably low enough that it's not going to create a discharge where that sharp end might,
Okay.
particularly, I guess, on a damp night, you might see it.
Okay.
Here's a corona ball, and here's a
There
real
you
one.
go.
I'm sure somebody's painted the ball a Corona extra.
I'm sure you're right.
Okay. I don't know so much about mobile where you'd have a solar cell, but definitely on portable operations, you may, like you're going out and doing POTA, something like that, where you're operating without a power source. So you might have batteries and a solar cells connected to it, keeping the batteries charged up. And all they do is convert solar energy into electrical power. It's called photovoltaic conversion. It's a semiconductor process, which we'll talk about in a few weeks, where it's a p-n junction that when light strikes that junction, it can cause current to flow and generate electricity. It's typically in the neighborhood of a half a volt per cell, assuming it's, getting full sunlight at 90 degrees and it's not cloudy and it doesn't have dust all over it and all those things that they don't talk about when they're selling you um, solar cells for your house. And it's usually some connection of a lot of cells that are connected in series and parallel to give you enough current and enough voltage. Most of the amateur radio type are running around, putting out around 19 volts. And depending on how many cells there are and how many are in parallel, will determine how much current it's capable of producing. Um, Most of the ones they sell, the panel may put out 100 watts and it might be close to a square yard or half a square yard, assuming everything is perfect. And you can connect more than one if you need more power. Uh, when you're using them to keep batteries charged up, and normally you're using either lead acid batteries or some of these new lithium iron phosphate batteries, which work much better. They're a lot more expensive than a typical lead or lead acid battery. You need to have a charge controller that works with the type of battery you have. It would be a different type of controller for a lead acid like automobile or motorcycle battery than it would for the lithium ion type. You also want to make sure that there's a series diode between the panel and the controller or storage battery. Because if there's a cloud or at night when it's not producing any voltage or it's producing voltage that's less than the battery, you would have current flowing from the battery back into the solar cell and it'd be discharging the battery, which isn't exactly what you want. So that series diode would only let current flow from the solar cell to the battery when the voltage is higher than the battery. So its purpose is just to prevent self-discharge. You could also use wind power, I guess in theory, to charge up your battery and operate your radio out in the park. I don't know if I've ever seen or heard anybody doing it. Maybe at your base station if you want to put a windmill in your backyard. It does require, depending on how much power you need, a fairly large array of storage batteries to be able to operate for any length of time. And you'd have to determine what your average power consumption is and then what the amp hour rating for the batteries are and how many of them you would need. And again, it's like solar. It's only going to charge the batteries when there's enough wind, just like solar is only going to charge the battery when there's enough sunlight. Okay, so what's the purpose of a capacitance hat on a mobile, or really any antenna?
To lengthen it. To Charlie.
Yep. What's the purpose of a corona ball on an HF mobile antenna?
It's true.
Delta.
Yeah, Delta.
Which of the following direct fuse power connections would be the best for a 100-watt HF mobile installation?
You said heavy gauge.
Yes, it's heavy gauge.
Alpha.
But to the battery using insulated heavy gauge. Okay, yeah, so alpha?
Alpha. Why should DC power for a 100-watt HF transceiver not be supplied by a vehicle's auxiliary power socket?
Oh,
That it was enough to.
Bravo.
Yeah, Bravo.
If your car even has one, although
yeah, they don't
mine does. They call them auxiliary power.
Yeah. But I don't think it's like you said, it has to be the 13.8 volts DC. And I'm not sure. But it seems like that plug only puts out the 12 volts, right? Is that what it is?
Well, actually, where the 13.8 came from is the nominal voltage of a charged 12-volt battery is 13.8.
Right. Okay.
And that's why amateur radios, mostly on the newer ones at least, operate from 12.8 volts so you can operate them remotely from a battery or in your car.
Okay.
Which of the following most limits an HF mobile installation?
Charlie.
Yeah.
What is one disadvantage of using a shortened mobile antenna as opposed to a full-size antenna?
You said bandwidth limited. Charlie.
Charlie.
Which of the following may cause receive interference in a radio installed in a vehicle?
You said
Delta.
and battery. Yep, delta.
All those bad things. In what configuration are the individual cells in a solar panel connected together?
Alpha.
Alpha, you said series parallel. Oh, yeah.
Right. You put them in series to up the voltage. You put them in parallel to increase the current. So it's usually a combination. You have enough series to get the voltage you want, and then you keep putting parallel strings together to increase the current.
Okay.
What is the approximate open circuit voltage from a fully illuminated silicon photovoltaic cell?
Bravo.
And it would be different if it was something other than silicon, although most of them are silicon.
Oh, I thought, yeah, I was gonna say Bravo. That's what I thought. Okay.
Why should a series diode be connected between a solar panel and a storage battery that is being charged by the panel?
Bravo.
I haven't had a chance to read them all yet.
Oh, sorry.
No, that's okay. You guys read so much quicker. Yeah, Bravo.
Okay. What precaution should be taken when connecting a solar panel to a lithium iron phosphate battery?
You need to put the
charge control. Delta.
Yes, Delta. That's Delta.
What precaution should be taken?
The ground framework to ensure the battery is placed terminals up, a series resistor. Yeah, I thought it said something about a diode in there, but okay, so that would be the resistor as the diode. So C, Charlie. Oh, dang it.
Yeah, the charge controller. Yeah.
Must have a charge controller. Yeah, well, we said that, but then he questioned it, so I thought maybe we was talking about the diode thing in there.
Just wanted to make sure you're paying attention. See,
Yeah,
it didn't say it.
Again, I thought you had changed questions or something.
It didn't say series diode.
No.
I'm trying to confuse you.
That's why I thought, well, maybe that's another name for it or something. I don't know.
No. Okay. All right.
All right. Don't forget your recording. Turn it off.